Hello, and in this video we're going to be dealing with the modeling with linear functions section. So basically we're going to be giving you problems that are problems that you could find in the real world or that are simplified problems from the real world, and they're going to ask you to solve them using a line prediction method. So this is the 8 steps of problem-solving strategies that they give you in the book. Basically, you need to make sure that you always read the problem carefully and identify the important information. So you're trying to find out what you're trying to solve for, what you need to assign to a variable. You may have to draw a picture to help you out, or you may have to do formulas. If you have to look up some formulas, you may need those to do that. Specifically, you're going to be using the linear formulas or linear functions to solve and evaluate in this section. So later on, this is the generic problem-solving strategy that you can use for any type of problem, but in this section we're going to be writing linear functions and solving linear functions. So basically you're going to you'd be using y equals mx plus b. Now, you want to make sure that you answer the question clearly at the end using whatever values that is appropriate. So if it's in feet, you're going to use feet. If it's in meters, if you're going to use miles per hour, then that's what you would be doing. So you want to use the appropriate units when solving this problem or these problems. All right, so what I've done here in this video is do 3 different types of problems that are found in your section. We're going to start with this first example. It says, suppose the world's current oil reserves are 1,820 billion barrels. On average, you're decreasing by 25 billion barrels of oil each year. It says, give a linear function or a linear equation for the remaining oil reserves, and they tell you the variables R and T. So R is going to be your remaining barrels and T is going to be time in years. Well, what we have here is we have the 2 numbers. They're giving you the 2 numbers for this thing. So your equation is going to be R of T equals some kind of T equation. So the T equation is going to be linear, because it tells you that, linear equation. So basically it's going to be m times t plus b. Okay, so we know that. Then it says 7 years from now, what will be the reserves? So you're going to use your linear function to create a prediction. And then if the rate of depletion isn't changed, when will the reserves be depleted? That means that you're going to actually ask when R of t equals 0, because you have been depleted, you have no barrels of oil at all. So first of all, we're going to go back to A. We know that this is the function R of t. What we want to look for in this problem is the rate of change and the starting value. Well, since this part right here says 25 billion barrels each year, that's going to be your rate of change because it says each year. So that's going to be your slope. So you're going to put 25 for the slope. And so it's going to be 25 t plus, what was the initial value? Well, it says the current oil reserves are 1,820. So 1,820 is your starting value. And this is in billions, remember. Billions of barrels. So any R that you're going to get out is going to be in billions of barrels. All right, so part B is asking you to evaluate R when you have from 7 years from now. So what you're going to be doing is putting 7 in here. Actually, we did do this in, it says decreasing. So I recognize that this is positive, so that's increasing. So this should be actually be negative 25. Negative 25 times 7 plus 1820. It says it's decreasing, so it should be negative 25, not positive 25. All right, so we would just take in negative 25 and times it by 7. Basically, you get 7 quarters there, so that's going to be negative 175 plus 1820. And that gives you 1645. So for part B, it's 1645 billion barrels. Okay, so that's the answer for part B. In 7 years, there'll be that much remaining. Now, in part C, they want you to know when is your depletion. So that means R of T is going to equal 0, which means that you'd write negative 25 T plus 1820 to equal 0 and then solve. So we subtract our 1820. We get negative 1820 equals negative 25T, and we divide. And we get 72.8. So that means for part C, the rate at which, when is it, so it's going to be within the 72nd year. So 70, so this is going to be, the answer to this one's going to be 72.8 years from now. It will be depleted. So in the 72nd year, it will be depleted. So that's one type. This type of problem is a problem, that will be given the slope and the intercept in the problem itself. So that you'll see a problem where they'll give you the slope and the intercept and have you write the equation. All right, in the second equation, or second type of problem here, it says you are choosing between 2 different window washing companies. The first charges $5 per window. The second charges a base fee of $40 plus $3 a window. How many windows would you need to have the first or the second company to be preferable? So that means, like here, if we do the first window on this one, this is only going to cost you $5, but the other person is going to cost you $43 if you just have one window washed. But eventually, the second equation is going to be cheaper because you're only going up by $3 per window, whereas the other one's always going up by $5. So eventually this one's going to be more expensive. Okay, so we will write a linear model for each company. So company 1, or we'll call it company A, is $5 per window. So that equation is going to be, since it's per window, that's a slope. So that's going to be 5x. So that's our equation. Company B is going to be $40 and $3 per window. So that's going to be 40 plus 3x. If you have $3 per window is your rate, so it's going to be 3 times the
how many windows plus $40. We want to know when would you have the second company be preferred. So what we're doing here is we're looking at when this is going to be less than that. So we're looking, we can find, let's find the intersection point first. Find when equal. And we did that in the last video. We want to set these two functions equal to each other. So 5x equals 40 plus 3x. Okay, and then to solve that, you're going to subtract your 3x on both sides and get 2x equals 40. So x is going to be 20. 20 windows is when they'll be the same price. So since this one is always going up faster, it's going to exceed the second one at 20 windows. So it says how many windows you have to have for the second to be more preferable. You'd have to say more than 20 windows. Or you could say 21 or more if you'd like to say, if you want to keep a whole window there, 21 or more. So 20 is when it's equal, but the second one is going to be more preferable at 21 because it'll be $2 less. How did I know that? Because this is going up by 3 and this is going up by 5, and that's a difference of 2. So it'll be $2 less at 21 windows. And it will be more than that after that, but only one difference is going to happen on the first window after the break-even place. All right. Now, here's my last example I wanted to go through in this section. It has a problem that deals with area of a triangle. It says find the area of a triangle. Okay, so basically you're going to have to go back and look up what's the area of a triangle. So area of triangle. So if I look up that area of the triangle, it's 1/2 the base times the height of the triangle. And so it has to look like this. Here's our triangle. I had a little picture of it that I've looked up. The base and the height are at right angles from each other. This is the height. This is the base down here, so they have to have a right angle there. So we're going to have to look at that in terms of this. So that's good that in this problem it says the line perpendicular. Perpendicular means that we're going to have a right angle. So we're actually going to have a right triangle in this problem. So we're actually going to do just this type of problem in this one because it's going to be perpendicular. We'll end up with this, and this will be our height, and this will be our base. Okay, we might have to change it around, but that's what's going to happen. I haven't done any work yet. I'm just trying to look at, see what I know, area of a triangle, and I know about perpendicular lines and how they meet. All right, so now I need to go back to the question here and find out what information I have. I have a graph here. I put a graph down here just because I need to be able to look at the drawing of a triangle to help me solve this problem. So I'm actually going to try to draw this triangle as accurate as I can here on this curvy straight line shape here. Okay, so this is our, first of all, this is our intercept and this is our slope. Okay, so I'm going to use this, the point, I'm going to use this intercept and the slope to graph this. So it looks like I need to be up 12 to graph this. So I'm going to start my axis down here so that I can at least be up 12 on this. So I'm going to put my x-axis down here at this line, not in the center. Put it in the middle here though. In the center going down. Okay, so there's my f of x-axis or my y-axis. Okay, so when I'm graphing this, let's start with 12 here. So we're going to put 12 in there. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. So here's 12. We're going to go down 1, so the slope is negative 1/3. So that's either negative 1/3 or 1 over negative 3. We can use either one of those. I'm going to use the first one. Negative 1 down and over 3. 1, 2, 3. So there's a point. 1, 1, 1, 2, 3. Here's a point. 1, 2, 3. There's a point. And the next one's off the graph. Okay, now it says it has to be perpendicular and pass through the origin. So to be perpendicular means that we have to have the opposite sign. And it has to be the reciprocal number. In this case, the slope is negative 1/3, so that means the opposite sign is positive. And the reciprocal of 1/3 is 3 over 1, which is 3. So we're going to need to go, I'm going to do the same thing, but I'm going to graph from the origin this time, because it says it passes through the origin, and it's perpendicular. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Wait. 1, 2, 1, 2, 3, 1, 2, 3. Oh, I didn't go over 1 on the last one there. Sorry. I went up 3, but not over 1. Okay, so I got to go back, make sure I count these right. 1, 2, 3 over 1. I got to go over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, so my line is going to go this way here, and it's going to go this way here. And it's bounded by the x-axis also. So that means x-axis is down here. So we're going to go this way. Okay, so it's going to go this way, and oh, we need some more room over here. Okay, so I'm going to have to go over here. I didn't leave myself a lot of room to do this. Okay, so basically I'm going to need to find out when this line crosses the x-axis down here, because I don't have enough there. So what number happens, since I not left myself enough room, I need to know when this function equals 0 when we get down to here, because we need to know that distance to be able to solve this problem. Okay, so let's set this function f of x equals 12 minus 1/3 x equal to 0 to find out when it's going to be on the axis. So I move I add the 1/3 x to both sides. I get 12 equals 1/3 x. I need to multiply by 3 to get x. So 36 equals x. So that means it's going to meet over here at 36. So way over here. Let's use a different color. Way over here. And that's going to meet clear over here at the number 36. Okay, so that's going to tell me the ordered pair here is 36, 0. Let's figure out, and this ordered pair is 0, 0, because that's it. And then we have to figure out what this is up here. Now this doesn't look like it crosses right at the nice number. So this only went up 2 and then over a certain amount. So it went up 2 and then over a certain amount. It didn't even actually go up 2 to get to this point. So it's in some range here. So what we're going to need to do is I'm going to need to set the two equations equal to 0 or to each other to find this thing. This one's equation is slope of 3, so, and it goes through the origin. So this is going to be, let's write it as g of x. So this is g of x equals 3x plus 0. Okay, we're going to need to set those equal. The 3x plus 0 equals 12 minus 1/3 x to figure out where they cross. We found out where that crossed. We know this one crosses here. We need to figure out that crossing point. So we would add the 1/3 x, and we get 3 and 1/3 x equals 12. We're going to multiply by, so this is, let's see, in a fraction, this is a mixed number. In a fraction, that's 9, 10 x over 3, or 10/3 x equals 12. I multiply by 3 to get rid of the denominator. So I have 10x equals 120. This crosses out here. This is multiplied by 3 also. X would be 12. That's not right. 36, sorry, not 120 here. Sorry, I made a mistake in calculations. 3 times 12 is not 120. 3 times 12 is 36. So x is going to be 3.6. All right, and then we know it crosses either one, so we're going to use g of x, 3x, to get the ordered pair that goes with that. So 3.6 comma something. So we're going to plug in 3 times 3.6 to get the g of 3.6, or the y value. So we do that. We get 18.8. Wait. We get 10.8. Sorry. 10.8. So this is our point. Let's just go up and look at our picture to see if it looks about like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it does look like it's up at 10 point something for the y, which is good. And 3.6, 1, 2, 3, yep. So that's our ordered pair there. Okay, so we have ordered pairs for the things. So this is our right angle, right? And I'm going to use this formula, B and H. So I need to know how long it is from here to here. And I need to know how long it is from here to here. Because that's B and H. We can, if we flip it upside down, then this is B and this is H. Well, we can't just count. It's not straight like this. If it was flat, I could count across and tell what B is and count straight up. That's okay. But this is at an angle. So we're going to have to use another formula besides the ones we have here to figure out how long that is. So that was done in the first chapter. That's the distance formula. The distance formula is going to need to be used. And we're going to have to do that twice in order to get this to work out. Once for this, using that point and the 36.0. So we're going to have to use 3.6 and 10.8 and the 36 and 0. And we're going to have to use the 3.6 and the 10.8 with 0, 0. Find those lengths. So if we do that, the distance formula, we subtract the y's. So this minus this, that's going to be negative 10.8. Okay, this minus this, minus 3.6 is 32.4. Okay, so we're going to get the square root of, and we're going to do those numbers up here, 10.8 negative, and we square it, and we add 32.4, and we square it, we get 1166.4 for that distance, which is approximately, when we take the square root, 34.1530. 34.1536. So that's that one distance. And then the distance on this other one is just going to be 3.6 squared, because that's 0 subtracting and 10.8 squared. So that's going to be the square root of using my calculator, 3.6 squared and 10.8 squared. This is going to be 129.6 when we add those up and square them. So that's going to be approximately 11.3842. Okay, so the area formula is what we're looking for. It's going to be half of the base, which we said was 34.1536 times 11.3842 is all right, I get 194.41 if we round. So we kept 4 places on these so that we can keep 2 on this one. So the more places you keep before, you don't want to round too much before you get to the last step, because then you'll have more rounding error. So basically we're going to say that in this problem, the area of the triangle from this pix is going using this formula, so is going to be 194. So area equals 194.41 square units. Because I don't know what the squares were up here, if they were feet or inches or miles. I don't know what. Basically what we're saying is there are 141 of these little squares in this triangle, about. I'm sorry, 194 squares in there. Okay, so this one used a lot of information. We needed the area. We needed to know about perpendicular. We needed to know how to find points on a graph. This required a lot of different things that you had to be able to bring up to solve the problem. But we started with the area because that's what they requested. We drew a picture. We needed to find the lengths of these two sides, so we used the distance formula to do that. And to use the distance formula, we had to have points. So we had to figure out the point, and the point here of the triangle to do that distance formula. Okay, that's it.